I'll do a mic check. Good morning. Good morning, Justin. Good morning. You're the only person I see in chat, possibly. Is morning, Zach. War Dog. So anyway, good morning, everybody. Or for those few of you who are here live, good morning. If you watch this later, then I hope that you've had a good start to your week and that this video finds you in a place where you've been having a good week, at least up to that moment. Anyway, hello everybody. We're in week 8, so let's just start by reminding you that next week, I'm going to go look at next week's content first. Next week is midterm week, so the only assignment that you have for the whole week is the midterm next week. I will be broadcasting on Tuesday morning, for review. You will have already had access to the exam by then, so you are free to show up to the live broadcast next week and ask questions, and I will answer them. So if you're motivated, you might go preview at least some of the midterm and start working through it and gather up a few questions if you have any. Let's go look at it real quick before I continue comments about that. Okay, so we are in week 8, which I'm going to come back to, but let's first go look at week 9. I'm just going to open it in a separate window so I can close it when we're done. And you can't see that, so that was pointless. I will open it instead in a new tab. Okay, so week 9, the only thing is the midterm. That's it. There's no discussion. There's no lab. My lecture next week will not be new material. It'll just be review material. So we'll just kind of go through a quick summary of the major things that we've talked about up to this point. The midterm has 50 questions on it. It is open book. There is no timer on it. So there's nothing that says once you start you only have an hour to finish. There is no timer. So you have the whole week to work on the midterm, but there's only one try. So once you've clicked submit on the midterm, that's it. It's submitted. Hopefully you know, a lot of you do, that your regular labs allow a retry, but there's no retry on the midterm. There's no time limit within the week that you have access to it, but there's no retry on it. So just to note, week 9, the only thing there is the midterm itself, and you have the whole week to work on it. 50 questions, 5 points apiece. They are all drawn as random selections from the first 8 weeks of the semester. There's more weighting toward recent weeks. So there's fewer questions from week 1 than there are in week 8, but there are questions from all 8 weeks in there. Okay, so that's the midterm. And then we're truly past the halfway point because we have 17 weeks. But this week is the midway point in terms of content. So that's pretty good. We're moving right along quite good. So let's go look at that. All right, so we're in week 8. I'll hide week 9. Week 8. So this week we are talking about processes and jobs. And in fact, I saw something that, let me go change my notes real quick. Because we need to make sure that we have some sense of the difference between a process and a job. This is one of the more sort of system administrator oriented pieces of content we've done up to this point, but even a regular user on a Linux system should know what a process is and how to control processes, and they should know what a job is and how to control jobs on a Linux system. And then there's details in there, like there's a foreground process and there's a background process, and what do those look like and how do you create and manage them. the PS command, the kill command. There's a few commands in there. But anyway, we're talking about processes and jobs this week. The readings seem like a lot, but most of them are just sort of covering the same material in different ways. So I hope that I have pulled together enough material there so that you have everything that you need to answer the questions, solve the problems on the lab. Okay, that's that. The lab assignment. So as always, there's hands-on experiments. They're fairly brief. I'll pop them open in a new tab. And I'm about to do all of these hands-on experiments right here while I'm broadcasting today. There's a list at the top of sort of the major techniques that I'm exploring in the hands-on experiments. And then you're going to see me use the sleep command a lot because it's one of the easier ways that I know of to get to experiment with managing processes and jobs in Linux. And then a few screen captures that show you the series of commands that I was running and the outputs that I was seeing. One thing you'll notice, you're going to hear about a thing called a PID, P-I-D, which stands for Process ID today. Your numbers are not likely, they're likely to look different. So if you see different PID numbers in your outputs, don't worry about it. It's highly likely that your PID numbers, your process ID numbers, will be different than what you see in these screen captures here. But otherwise, you can see where I've entered a command and what is being displayed by the shell. And then I do a series of commands, a couple of sleeps, jobs, a process, a kill. Anyway, so those two screenshots are sort of just a good start for experimenting. And what I encourage you to do is run some experiments for yourself, just to develop a feel for what is a process and how do we control them, and what is a job and how do we control them in Linux. So not tons of hands-on experiments this week, but I figured that the concepts for a lot of people, especially if you're not on the system administrator side, then processes and jobs are likely to be very new to you. And then I'll try to incorporate some Windows terminologies to draw parallels as we get going. Okay, so there's a hand-on experiments. The discussion is just trying to give you a week off, but still have us all out there reminding us that we're all in this together. So that's a lot of what Piazza is just a regular reminder that, hey, we're all out here, we're all doing the same work, we're all trying to learn. And occasionally if we can pitch in and learn together, that's great. But this week is just go in there and say something nice on Piazza, leave some positive note of encouragement for your classmates and yourself as we go into the midterm week. So that should be easier than the normal ones that require a little bit of research. And then the reminders. So the big reminder is that the midterm opens up on Monday next week, the 19th. And it is due by Sunday night, the 25th. And that is the only assignment for the whole week is the midterm. And then not that long after that comes the first team project. So I sent out a message to everybody encouraging you to contact your teammates. If you haven't done so, please consider doing that sooner than later, since probably you're going to want to focus your energies on the midterm next week. Okay, so that's where we're at. Now I'm going to switch up views and let's go work inside of our Linux systems. Okay. Before I do that, let's get no. Let's go in, and it might be easier for me to make these definitions if we're inside of Linux working. Okay, so a process in Linux, when we say process, all we mean is a running program. That's it. A process is simply a program that's currently running. In the Windows world, you would call this a task, and there's a task manager that allows you to view all the running tasks and view how much CPU they're using and go and terminate them if you want to, which we in the Linux world call killing the process. But a process is simply a running program. You'll see the word instance of a running program in there, which I'll show you an example of. But a process is just a program that's currently running. In Linux, the command that you can use to view the processes that are currently running, that are running for you, is the ps command. So if I type the ps command, it's going to list for me. Now this is not actually all the processes for me, but these are sort of my most immediate processes. My shell process, which for me has a process ID, this PID, of 5549. Your numbers are likely to be different. And then you'll also notice that the ps command itself became a process temporarily while it ran. And if I run the ps command again, you'll see it's the same shell process because my shell has continued to execute the whole time, but it's a different process ID for the ps command because that is a different execution of it, a different instance of ps ran the second time that I launched it. So that's fairly straightforward. You can also, on a Linux system, list processes by username. So if I do a ps-u and my username, which happens to be user on this system, you'll actually see that there's additional processes associated with my user. These other processes are related to the underlying system getting me logged in, and I'm simplifying but some other things. We're not going to really worry about since this is really an operator course, we just want the most sort of direct usages of PS and the most direct meaning of process. So I'm going to clear, just remind you what my processes are. My shell, same process ID here. And then the ps command, which ran under a different process ID because it was a different instance or execution of ps when I ran it this third time. Okay, so that's a process. We're going to do a little bit of mixing and matching here. So that you can get a feel for the way some of these things work. And also I want to show additional processes. So the first thing I'm going to do is I'm actually going to execute an additional bash. Now this seems weird, but what I'm doing actually is now I have my original bash that I logged into, and now I am running an additional bash on top of that. And if I do ps, you'll notice I have two bashes now. I have the bash that I logged into, it's still running under there. And now on top of that, I have a new bash that I'm currently running in. So you can actually run layers of bash on top of each other. There's often no practical reason to do that, but it's interesting for experimental purposes to do this. So there's my original bash, process ID 5549. And then the bash that I just launched on top of it, which is process ID 5584, and then the PS instance that I ran to get this listing. Okay, so now if I exit out of this bash, what that does is it drops me back to the original bash layer. So if I do a PS now, the second layer of bash is gone because I exited from it. And then back down into my original login bash, which has the original login original process ID of 5549. Okay, so there's that much. Now I'm going to do, I'm going to use the sleep command for this. Let me bring up the manual page for sleep. So sleep is kind of pointless by itself most of the time, but it's very, very useful for doing experiments with processes and jobs because sleep allows you to control how long it runs for. And the basic purpose of sleep is you pause, it's its own program, so it runs, but it basically causes a pause for some number of seconds. I'll show you what it looks like by itself. So if I sleep 3, for 3 seconds, I have to sit here and wait until it comes back. And if I sleep 10, then I don't get my cursor, my command prompt back for 10 seconds. So that's all sleep does, is it kind of just takes over things for a certain number of seconds, but it's very, very useful for doing experiments with. So the first thing we're going to learn with it is how to run a process in the background. So in fact, before we do that, let's learn how to interrupt a process. So if I do sleep 300, that's 300 seconds, and that's 5 minutes. 5 minutes until I get my command prompt back. So if you ever find yourself running a process, like I'm doing the sleep process right now, and you don't want it running anymore, you want your command prompt back, the sort of nuclear option is Control-C. So you can see that the shell kind of printed some characters, so that's Control-C. That's called interrupting the process, but it effectively kills the sleep 300 process. So sleep is gone. If I do PS, there's no sleep process there. So Control-C is called interrupting the process, and in most cases what it means is it terminates or kills it, stops it from executing anymore. And you can tell that's true because when I ran PS, it didn't appear in here. All right, so there's Control-C. So another way to do this, though, let's say that I want it to run for the whole 300 seconds, but I want my command prompt back, then I can launch this process in the background. So if I put this ampersand here, it will run in the background, and what that means is it will begin executing, but I get my command prompt back. So sleep is back there actually doing the sleep thing, but I have my command prompt back and I can do stuff. So this allows me to run that program and regain control of my command prompt so I can do other things while sleep is off finishing its work. If I run a PS right now, there it is. There's the sleep. So it's out there, it's still running. And it will keep running for 5 minutes. If I run it another one, I'll do a sleep 600. Now technically this is 10 minutes. And I'm going to run it in the background. You'll notice the immediate display. It's telling me 2 pieces of information, but for now we're just going to worry about this longer number. That's the process ID. So that new sleep that I just ran is process ID 5642. If I do a process listing, the original sleep is still out there sleeping. The new sleep is now sleeping for a longer time. And they are just running. So that's backgrounding, the ampersand, this character here. So the idea of backgrounding is that you can launch a process and regain control of your command prompt after you do it. Okay, so those are those steps. Is it still running? Yeah, it is. I have like 5 minutes before it runs out. So now let's add the kill command. So the job of the kill command, it actually does a lot more than just kill a process or terminate it, but that's going to be our first use of it, is to terminate a process. And the way you do that is you say kill, and then you say, it's called a signal, which -9, I think I put it on my list, didn't I? I didn't yet. We'll go look it up. Anyway, this -9 signal means I want to terminate this thing. So I'm going to kill 5640. So that's the process ID. -9, I'm going to show you in a second the different signals you can send to it. And kill isn't actually a process terminator only. It will do other things to processes. It will suspend them in the middle of their execution, as an example, and some other things. But this -9 means I want to terminate the thing. So if I run a process listing now, you'll actually see that the shell realizes that someone came in here and killed this, terminated it, and that was us. So notice now the PIDs that are running are 5549, 5542. That's that 600-second sleep, and then the PS that I just ran. So let's kill the other sleep. That's process ID 5642. If I run the process listing, now it notices that I've killed that sleep 600 one. So when would this be useful, this kill -9 thing? If you have a program, I'm sure most of you have done it on Windows. On Windows, you'll get a program that says not responding, and you can use the task manager to go terminate it. This is kind of the same thing. Kill -9 is a way, often what we would use it for is to terminate a process that has malfunctioned somehow, that's not responding anymore, or for some reason we don't want it executing anymore. We do kill -9 on it. Run the PS. So back to my original. I want to show you what happens, by the way. Let's try it. What happens if we kill the shell process that we're currently logged into? You might be able to guess. Yeah, it's a good question, Justin. So we're about to give it a shot, and let's see. So if you want to wait until mine does it, you can, just in case. But I'm about to do it. So it bounced me out. Basically, I'm no longer logged in because the shell that I was connected to was killed, and that ended my login session. So it's an excellent question, Justin. It was perfect timing because that was a good experiment to run. So if you kill the shell that you're logged into, you lose your login, and you have to log back in. Yeah, pretty neat. By the way, that's a good nuclear. If you have someone who's exploited your system and you catch them being logged in, that's one way you could bounce them really quickly, is to terminate their shell process. Any hacker worth their salt, by the way, is going to want shell access to your Linux system, because from there they can access all the commands that they might need. So PS, notice my bash process ID is different now, and every time you reboot, these numbers will change and start counting up again. So this is a different instance of bash because it had to relaunch it for my login. Okay, so let's look at kill, the man page for kill. So its primary process is to terminate processes, which is what we were just doing. Now I sent it the -9, and you can see here in the description, if no signal is specified. Now I specified the -9 signal, 9. But it says if no signal is specified, then terminate is sent. The default action is to terminate the process. In fact, they tell me I shouldn't have been using -9, but it's my habit. We'll try it and let's just see what happens. So I use the actual kill. So kill -9 means kill. But a kill -9 means that process has no choice but to terminate. If you do term, the process actually has a choice a little bit. Anyway, the whole job of the kill command is to send a signal to a process. You have to know the process ID, so you use PS to get the process ID, and then you use kill to send it a signal. And then there are some options, but the main ones you need to know is kill followed by a signal followed by a process ID. What does -L do? Print a list of signal names. Alright, so let's look at that. But we'll print signal names and numbers. Let's use the big L. So this is a lot, but this -L option is telling you all of the choices you have for signals to send to a process. I was sending 9, sig kill. And what it's saying is its default is sig term. If I can find it, that's number 15, sig term. So let's experiment with that just a little bit more before we go too far. So here's my current processes. I love using sleep for this because I can make sleep, I can just do a sleep process for a very long time, and that gives me plenty of time to relax and figure out what I want to do with it. So 5752 is the process ID of my sleep for 10 minutes command. There's the PS for it. So kill says if I just give it the process ID, it's actually going to send signal 15, which is the terminate signal. Notice, by the way, that's different from the kill signal. Let's see if it did it. Okay, so you can see a difference. It's no longer running, but notice that the system recorded that as a termination as opposed to a number 9 kill. So that's interesting, isn't it? This part's a little bit tricky, but when you send signals to programs, what that program does with that signal is most of the time based on the programmer who made that piece of software. So I've written software where I have ignored some of these signals in my software so that they can't be killed in the usual ways. Now that's a little bit beyond our needs. There's my processes, so I'm going to run the sleep again. 5757. So let me just show you the different ways you can use kill. So if I do 5757, that by default sends the terminate signal. But you can also send the terminate signal by its number, which is number 15. We just saw that in that listing. Or you can send it by its name. So you have a whole bunch of options for the way you send signals to processes. Sig term is sort of the nice way of asking a process to shut itself down. So there it's been terminated. That's the nice way of doing it. I'm going to use this listing again. So sig kill is the not nice way of asking. So if you ask a process to terminate itself nicely, it actually has an opportunity to do some cleanup work. If you do a sig kill on it, not nicely, it just immediately gets wiped out by the operating system. So let's do an experiment with that. 5763, so I'm going to kill, so you can use the name of the signal or the number of the signal. -9 is quicker to type, which is what I usually do for kills. But you can also use the name and then the process ID. And then the shell will record the fact that that one was killed. Now, in both cases, the process was actually shut down or terminated. But sigterm is sort of a nicer way that lets the software clean itself up, whereas sigkill just stops it dead in its tracks. And anyway, you can try other signals. There's sig interrupt, for example. If you see here, number 2, we're going to try that one and just see what happens. So I'm running sleep in the background so that I have lots of time to experiment with it. So let's see what happens if I run a -2. That's sig interrupt on 5769. So notice, but the shell is sort of picked up on the fact that that actually was responding to an interrupt. So it's going to feel weird at first, but in this case, sigterm, sigkill, and siginterrupt all caused my sleep command to terminate. And that may or may not be true depending on the application or the process you're trying to kill. Probably. I've never actually done a sig pipe manually, so the question is, does sig pipe add a process as it kills? I think that's very possible. I'm going to try it because the worst thing that happens, I'll just exit or log out. Let me show you one other thing, by the way. So Sleep 600, when I did a Control-C, that's actually a keyboard shortcut for sigint, for sending the interrupt signal to a process. So if you have a live currently controlling your terminal process, you can send it interrupt sigint number 2 with Control-C. Let's try sig pipe and see what happens. That's number 13. Okay. I just taken the PID right off of here. This one just says broken pipe. Is it now gone? We'll have to look into how that one would be used manually. But in this case, it just caused sleep to shut off. My guess is, Justin, that piping, since it's a way in the shell that we use to connect processes together, that somehow we can use this to connect 2 processes together, if we were clever about it. Okay, so that's backgrounding, that's PS, that's a little bit of the kill signal. So we're going to do one more, and that is, let's list it. So where is TSTP? TST, so see number 20 here. That stands for terminal stop, which sounds weird, but I'm going to send a terminal stop to a process. So, okay, so I'm going to send a TSTP, which is also a number 20, to 5780. Okay, so this one's a little bit different actually, because what it has done is it has actually suspended the execution of that process or stopped it. So Sleep 600 is not executing actively, but it's still out there, even though its current state is that it has been stopped, which is kind of interesting. So let's try to continue it. which is what I think number 18 is. We'll find out. My guess is that it's currently executing. Again, I'm going to cheat. Don't look. Yeah, it's running. Now, we haven't talked about jobs yet, but I just used the jobs command to see if it was actively running again, and it was. So I used the SIG TSTP, that stands for terminal stop, on a process, which interrupted. It didn't kill it, it just stopped it from actively executing right now. And then I used a continue on it, and that put it back in running state. So it was stopped, and now it's running again. So there it is, and I'll go ahead and kill it. I'll just kill it in the nice way. If you don't specify the signal, then it's asking nicely if it will stop running, and it did. So that's a little experiment. Hopefully you're kind of getting why I use sleep this way. Okay, so one of the things that I did, I just did a SIG TSTP. And there's a keyboard shortcut for that signal as well. So right now Sleep 600 is running. You can use Control Z, which is the keyboard shortcut for stopping an active process. So Sleep was controlling my terminal. I used Control Z, it prints out here on the screen, and that put my my Sleep into a stopped state, which means that it's not actively executing. It has to be resumed or killed. If I do a PS, it's out there. So Control C is a shortcut for interrupt, SIGINT, number 12, I think. And Control Z is a SIG terminal stop, keyboard shortcut for it. So in those cases, those are fairly common. I'm going to kill that before we... I'll let it run. It doesn't really matter, does it? Okay, so I'm going to open up a Vim file. I'm just going to call it test. Hopefully I don't have one of these. So now Vim is executing. And I'm going to use Control Z in here. I'm actually going to send a stop to Vim. And you'll notice that I drop out of Vim, and then the shell tells me it's been stopped. So I'm not in Vim anymore. If I run PS, there is a Vim process out there, but I know because I stopped it, it's not currently executing. Okay, so let's see where we're at in terms of my little notes here. Backgrounding. Okay, so now we're up to talking about jobs. Okay, so a process is an instance of a running program, that's it. And notice that I have 4 of them right now. A job is a program that is being managed from within your shell, actually. So a job is a process, and every job is a process, but not every process is a job. And the way I can prove that is by using the jobs command, which will tell me what processes are actually being currently managed in my shell. Only 2 of them, the sleep and the Vim. Those are my only 2 jobs. Those are the only 2 processes that I'm actively managing with my shell. Those aren't all of my processes. They are 2 of my processes, but they're not all of my processes, because my bash process and that PS that I executed, I'm not managing those in any way with the shell. I am managing the sleep command and the Vim command with my shell. And the way I'm managing them is that I have currently put them in a stopped state, and they have to be, they need to resume running to finish. So that's where we're at now. We're on jobs. A job is a process that's being managed by the shell. A process is just any program. A job is a special kind of a process that I'm managing with shell features. So these are both being managed. They've both been put in a suspended or a stop state. Hopefully on my screen, on your screen, you can see the minus and the plus. So the plus is significant to us here because what I'm about to do next is I'm going to bring a process or a job back into the foreground. So if I type foreground and press enter, the job with a plus next to it will continue executing. And here I am in Vim. I can't spell today. That's why I'm not talking, because I'm having spelling problems. So Vim became a job when I used Control Z to suspend it. Before that, it was just a process. It was just another program running on the system. So foregrounding is a way that you can return a job to executing status, to running status. So I'm going to write and quit from my Vim. If I list my processes, Vim is no longer there because I quit out of Vim. I did a write and quit. If I look at my jobs, the Vim job is no longer there because I foregrounded it and then finished my work and then exited out of it. So here it shows that the Sleep 600 is the only job right now, and if I were to use foreground, that sleep is the thing that will return to executing status. And there it shows me Sleep 600 back online. Now I'm going to use Control C to interrupt it. All right, so we're on to the jobs part. A process is it's an instance of any program that's running. A job is a process that is being managed in the shell. Okay. So we're looking at jobs. The way you're normally going to experience jobs is that you're going to background or suspend them. So let's use the jobs view. Just make sure I don't have any stray processes running. But let's put a sleep in the background. And then look at jobs. So that number that's been printing the whole time, when I backgrounded something, that actually shows me that when you background something, that also makes it a job. That makes it a process that you can manage with the shell. So it's currently running. It's running in the background, and if I want it to come back to the foreground, I can foreground it. And then I can use Control C to interrupt it. So now we're going to run a few and play with them a little bit because the numbers do have some use. I'm going to use some bigger numbers now. So I'm going to background a 1200 second sleep. I'm going to background a 1500 second sleep. I'm going to background an 1800 second sleep. And we see the process IDs because they are all processes, but we also see job numbers because if I put them in the background, now they become a process that's a job that I can manage with the shell. So here's the process listing. They're all there. I can't actually see which is which. It doesn't show me which one's the Sleep 1200, although I can guess that the Sleep 1200 is the lowest number. But if I list it as jobs, I can see them all running there. All right, so now let's play with them a little bit. So if I bring something to the foreground, just by typing FG, it'll be the one with the plus next to it. I believe that you can actually use the percent sign and the plus to specify the job that has the plus next to it. And there it is. That's the 1800 second sleep. Now I'm going to control Z to suspend it. So now the 1800 second one is stopped. The other two are still running. So I'm actually going to foreground the job with the minus next to it, which is the 1500 second sleep. And I'm going to suspend it as well, control Z. I'm going to clear and refresh. So job, so those first two are now stopped. So I want to suspend this one, this number 1 job. So you can also use the percent sign to target a specific job number. So I'm going to foreground that one, and then I'm going to suspend it. So now they're all out there. They're not currently executing. They're waiting for me to resume them. But I wanted you to see the way you can target things with foreground. Okay, so that's foregrounding. Backgrounding should, but let's try it. I'm going to type BG and then jobs, and let's see what happens. So hopefully you can see what happened here. When I typed BG, which is background, what that actually means is take a job that's currently suspended and begin executing it again in the background. So notice that the number 1 job, the one with the plus next to it, BG, the one with the plus next to it, is now in a running state after I did the BG command. So if I were to do BG again, it's going to target the one with the plus next to it, the 1500 sleep. Now it's running again. I can also target the +1 or the -1 or the job number with the background. And now they're all running again. I don't use this feature a whole lot, but it's a part of this class where everyone's supposed to be exposed to the idea of a process and a job. I do kill processes sometimes on Linux as things that are, my fault or whatever it is. Occasionally I use this functionality, but not a whole lot. But anyway, those are jobs. You can foreground a job, which means take a job that's currently running in the background as a job and give it control of your terminal and let it run in the foreground again. The background command takes a suspended job and resumes its execution in the background. So it lets it keep running, but it doesn't take control of your terminal. You can also, by the way, let me make sure that you can also use kill on your jobs. So if I try to kill, let's try number 3. You'll see that the number 3 job was terminated. If I use process again, there's only 2 sleeps left. And that's because one of them has been terminated. So you can actually use the kill command on your shell jobs just like you do on the process IDs. There's my jobs. So I can kill, I'll kill the one with the minus next to it. Shows that it's been terminated. And then I will foreground the 1500 sleep. That's the one with the plus next to it. And then use Control C to send an interrupt signal, or in other words, kill. So now I have no jobs, but I do have my original 2 processes. So for my money, the best way to develop your own feel for this is to just experiment. As long as you're not root, pardon me, as long as you're not root, you're not going to cause yourself much hassle. You might accidentally log yourself out, but you're not likely to wreak that much havoc. So it's a fun one to experiment with. Hold on, I'm going to clear my throat. Okay, I think it's better. We don't need this man 7 signal. I'll just use the kill-L instead for that. That's most of my stuff. So the tricky part is, and I'll just put a reminder down here. You want to make sure that you understand a definition of process and how that's different from a job, which will be very helpful. PS is to list processes. Jobs is to list jobs. And they are related to each other. So that's sort of the tricky part, is that they do cross over each other a little bit. That's most of my stuff. If you're a system administrator, you will make a lot more use of these utilities than if you're a regular user. But it's useful to know anyway, because you never know when you're going to end up on a Linux system and you launch a piece of software and it seems like you lost control of it. Well, you can use processes and or jobs to get control back of the thing. Okay, I think that's it for me. I hope the coverage was adequate for your needs. Processes and jobs. It should all be here on my notes. The things that we did. I know that the hardest part, or at least I think the hardest part, is the signals part. You don't have to worry tons about that. The main thing to come away with is that the kill command is how you send signals to processes. It sounds like it would only be used to terminate processes, but it can be used to change the state of processes, for example, to suspend their execution and then continue their execution later. Also, you can use the kill command to control the state of processes and jobs in Linux. It's pretty cool. The closest parallel to this in the Windows world is the task manager. So if you've done an Alt-Control-Delete in Windows and looked at the task manager, that's a very similar bit of functionality to what we're talking about here. I think that's it. So thanks for being here if you're able to be here live. If you're seeing this later, hopefully this does what it needs to do to make you successful in the lab work this week. I will be broadcasting on Tuesday morning next week, review. So what I will probably do is just kind of run through the commands that we've encountered up to this point, and make just a brief summary comment about each of them or something along those lines. But I will also be available to answer questions. So if you have time to preview the midterm on Monday before submitting it, then on Tuesday morning you could come to the broadcast and ask questions if you wanted to. So anyway, I'll be here. I'll be doing review. No new content this week. It is midterm week. Other than that, I hope you have a good week, and I will see you next Tuesday morning. Thanks, Justin. See you next week. War Dog, thanks. Commander Root, thanks for being here. Everybody is here if I can or can't see you in chat. See you on Tuesday morning next week. Take care, everybody.